Hi everyone. This is Dr. Satish from Manakron and Technology. I have some problems to say from chemical kinetics. But one thing I want to clearly say. So this video is going to be only a problem solving video. Particularly, I want to help the students who want to write competitive exams like GATE, CSR. And also, some problems may be useful for TRB exams also. Okay. So as far as chemical kinetics is concerned, more number of problems are being asked. So starting from Arrhenius equation, steady state approximation, fast reactions, uh, some other reactions, some advanced reactions are also there. Okay, so the more number of problems are asked from this topic. See, here, I don't want to say anything about theory. So if you want to learn theory, you just refer your textbooks and get the input. Okay. Good. So the first problem is from Arrhenius equation. Now, what is this? First of all, see the problem is in many competitive exams, the students ignore physical chemistry problems. So as I did. Okay, so actually the physical chemistry problems are very useful and they are very easy and very easy to score marks in competitive exams. So compared with your organic chemistry and inorganic chemistry, so the only problem is you have to practice more number of problems like this. Okay. See, so what is the first problem? So you read this. The rate constant for the decomposition of hydrocarbons is 2.418 into 10 to the power of minus 5 inverse second. So at temperature 546. First of all, you have to write down the data. So what is given and what is asked. So here the rate constant is given, temperature is given, energy of activation VA is given. Okay, activation energy is given. So only the pre-exponential factor is asked. So you have to immediately have to write down the Arrhenius equation. So what is the Arrhenius equation? Eliminate. Okay, sorry. So let us continue. So immediately you can write down the Arrhenius equation. So what is Arrhenius equation? K is equal to A power minus EA by RT. By RT. So K is given. So what is K? 2.418 into 10 to the power of minus 5 seconds, which is equal to A is asked e power minus Arrhenius value is 179.9 divided by 8.314 into what's the temperature? 546. Okay, so 544. So these are all the values. So I have substituted all the things. So next you have to simplify them. So how to calculate the value of A? So A is equal to 2.418 418, 2.418 into 10 to the power of minus 5 divided by power minus 179.9 divided by 8.314 into 546. Okay. So I can strike out these things. Okay. See, upon simplification, I can get 2.418 into 10 to the power minus 5 divided by e power minus r minus 179.9 divided by 4,539.42. Okay. So upon simplification, I can get 2.418 into 10 to the power of minus 5 divided by e power minus 39. E power minus 39.63. Okay. So when the exponential side moves upwards, it becomes 2.418 into 10 to the power of minus 5 into e power 39.63. So upon simplification, I can get the value of A as 4.2 into 10 to the power of 12. Okay, so this type of questions can be witnessed in majority of competitive exams. So I have solved one such questions. So next question is, see, interesting question. Deduce an expression for time if it takes for the concentration of the substance to fall to 1/3 of its initial value in an nth order reaction. So for that, you have the general formula to calculate the rate constant. So what is the general formula? Kt is equal to, wait, so I think I'll memorize it. Kt, okay, Kt is equal to 1 by n minus 1 bracket 1 by a to the power n minus 1 minus 1. So it's, wait. Okay. So we can continue. 1 by n, 1 divided by a to the power n minus 1 minus of 1 by a0 to the power n minus 1. Okay. So here A stands for the concentration after the time interval of t seconds, where A0 stands for initial concentration. So what is asked now? They are asked for an expression for time. At the same time, the concentration has to fall 1/3 of initial value. So the initial concentration is A0. Okay. So initial value is A0. But after the time, when 1/3, A0 by 3. So therefore, you have to substitute the value of A as A0 by 3. So therefore, we can arrive at the answer very easy. 1 by n minus 1 into 1 by a0 by 3 so n minus 1 minus of 1 by a0 minus 1. Okay. So this is the initial substitution. So next step, what is the next step is equal to so in the next step I can write it as equal to 1 by n minus 1 bracket okay, 1 by a0 to the power n minus 1 divided by 3 to the power n minus 1 minus of 1 by a0 to the power n minus 1. Okay, so now I can rewrite this equation as 1 by n minus 1 into e to the power n minus 1 divided by a0 n minus 1 minus 1 by a0 n minus 1. Okay. So if you take LCM, both are common. So therefore, I can write it as 1 by n minus 1 into 3 to the power n minus 1 minus of 1 divided by a0 to the power n minus 1. Okay, so this is the one format of writing this equation, but you need only time. So therefore, you can introduce, you can go for one more step. So therefore, I can write it as Q, Q equal to to take this to upward. Therefore, I can write it as KT is equal to 3 to the power n minus 1 minus 1 divided by n minus 1 is the bracket. So the a0 moves upwards, n minus 1 becomes 1 minus n. 1 minus n. So it becomes 1 minus n. T is equal to, so this is the formula. But what is asked for us temperature? Sorry, the time. time taken, the time required to convert the initial concentration to 1/3. So therefore, 3 to the power n minus 1 minus 1 divided by n minus 1, close the bracket, is 0 to the power 1 minus n. So when it is in 1 by n, so the A0 n to the power minus 1 becomes. So when it moves to the numerator, it becomes 1 minus n. So that's all. Okay. Thanks a lot for your patient watching. So we shall meet in the next lecture. Thank you.